between Rough and UV and things like Pydantic, modern Python development is so different than what people have expected from the past. It's in like the type hints are getting better with every version. Python's event loop is ridiculously performant now.
Welcome to Fork Around and Find Out, the podcast about building, running, and maintaining software and systems. This is an ad spot, but because we don't have a sponsor that paid for this spot, I just want to take a moment to thank everyone who downloaded, listened, and shared these episodes with friends. Thank you especially to the people that rated the show on various podcatchers. We've been seeing the comments, we see the ratings, and we thank all of you. The podcast is already off to a great start. We've only put out a month of episodes, and it's already blown away all my expectations for how many downloads and people subscribing. If you want to reach these subscribers and you want to help this podcast to last long term, please consider sponsoring. You can find the sponsor packages at fafo.fm/sponsor, or you can send us an email at sponsor@fafo.fm. I know there's a lot of F's in that URL, but I promise you there's many, many more in the podcast itself. Thank you all for listening and keep that feedback coming. Hello, everyone, and welcome to Fork Around and Find Out. I am your host, Justin Garrison, and with me, as always, is Autumn Nash. In today's special episode, we have Ada Lundhe talking about how chaos monkeys and just controlled chaos can be a good thing for you. And you really hooked me with this story about Rachel Ray taking down a website. So we'll get into that in just a second. Ada, tell us a little about yourself. What do you do? What have you been doing tech, and what are you kind of...
So, hi, I'm Ada. I am a lead engineer at a company called Datavant. I work on a variety of systems. I'm kind of a smorgasbord. I've done everything from web dev. I got my start, as anyone does in Montana, working on like PHP, WordPress websites, and then shifted into like the usual suspects, 2016, 2017, early Angular and JavaScript, like React development, taught at Code School. Then I shifted into like test and then machine learning engineering and DevOps. And I've kind of been all over the place. I can reasonably impersonate about 6 different types of engineers. It's fun.
You said reasonably impersonate.
I'm like 6 devs in a trench coat. What I really like to do though is
I was just going to say in a trench coat.
Yeah, it really does feel like that some days where I'm just like, yeah, I can author a front end. Am I as good as like a seasoned web engineer who is like, spent 12 years doing CSS and React and things like that? No, of course not. But do I know enough to know that, how to avoid like accidentally putting use effect into an infinite render loop? Sometimes.
I feel like that's all of being an engineer. You're just like faking it till you make it and just pray that like...
That's my entire backstory.
Unless you're like super in depth in one area and that's the only area you work in, like you're just a jack of all trades trying to...
And pretty much every other field, you just have to know enough to know what questions to ask, right? Because you're like, I just need to know which direction should I go in so I can discover what the answer is. And as long as you can get down that path, you're fine.
That's really what it is. And it's funny because even when you talk to a lot of those specialists in tech, that's how they got there. It's just they kept going down the same rabbit hole.
It's also how half of us have ADHD because like we live in a rabbit hole.
Yes, I was diagnosed with autism at the age of 5.
Me too.
And it shows in this very room that I'm in. This is not a specialist subject at all.
Great hobbies, okay? Like
I'm counting like 12 keyboards behind you.
Oh, it gets so much worse if I turn. Like, okay, hold on. We're doing this. Okay, so yeah, those photos are not AI. Those photos are just this room.
For anyone that is listening to this podcast, I'm sorry, but also this is like a whole studio in what looks like a large walk-in closet.
It's the third bedroom of the house, and this is 15 years of gear addiction. Everybody knows it. It's called GAS, gear acquisition syndrome.
I have a different kind of gas. This is
Oh, it's a studio. It's funny because a lot of how I got into tech actually was through this kind of thing, because these same sort of skills used in like music engineering, audio engineering, music production, these sorts of things are a lot of the same general skills, general problem solving that you'll use in tech and that you'll find very useful in tech. It's this mixture of very scientific, very technical, very detail oriented work and a degree of taste or artistic like choice to some degree. And I think even if you're writing the like most boilerplate backend service, there's a degree of that, right? I think this is part of the reason why I fell in love with like software engineering and building systems and like coding, particularly building like internal tooling and stuff like that so much, was because it's this blend of very precise technical in-depth knowledge. Like you can really get into the mathy side of it and all that sort of thing. And then, but also there's just this expressivity, there's this creativity with it that makes it so much fun. You can explore and build just wild and wacky things. We'll get to that. But it's one of those things where also just like I originally graduated in 2013 with an English degree, and I thought it was terrible at math, at like science, at all these things. My dad used to have a saying, which is, I love you some, but if you tried to land a rocket on the moon, you'd land it in Detroit. And he wasn't wrong. I just did not get along with math well for the longest time. And then on kind of actually because of my partner that I've been with now for 11 years, seeing her level of learning, I was just like, well, I have that level of learning. And you know what? I always have like admired folks like Rupert Neve and I forget the name of the CEO of Atom Audio and all these guys that have these like very like technical, but not necessarily traditional backgrounds. Although I think the CEO of Atom Audio actually was like a full physicist for a long time. And I want to be able to go into that. Like I want to learn how to write like DSP and how to write like software plugins, VST plugins for like audio and stuff like that. And so I went back to school for sciences and I ended up finishing a computer science math dual post back. And my work in audio actually funded a majority of like the textbooks and like a good chunk of tuition and stuff like that. And as well as just like working in tech the entire time in Montana, because I don't know if it's still true, but like back from like 2014 to like 2020 in Montana, there was just like every place needed some sort of just like WordPress, PHP, Journal dev person, and there was a small, growing startup scene up there in Montana. It's funny how this all like comes and plays in, and I still love to do it because it's like I'll get done with work for the day and I'll come over here and it will be very much like similar skills. So I'm still kind of working that muscle, but it's a very different outlet.
The different keyboard. It's just from QWERTY to 88 keys. Yeah.
Yeah, QWERTY to knobs and whatever wild sounds I decided to come up with at a given time.
Before we dive too deep into the technical side, are you creating music? Do you mix it? Do you produce? I mean, I know usually it's like all of the above, but like what do you usually focus on? Do you like?
I like doing mixing and mastering for other folks for the most part. I've always felt more comfortable kind of as a studio rat, kind of, behind the scenes. And then I do commercial audio for clients and stuff like that. I have a decent client base I've built up.
So we could hire you for a Fork Around and Find Out theme.
Yes, actually you could. It's very fun to me to explore and to create these sounds. I guess kind of diving in then to the major topic here, which is just like those rabbit holes and things like that. If I were to have a like background specialty, it would be building tooling, and in particular like internal tooling, test tooling. And that leads to I guess today's story with like Rachel Ray and things like that. So back in 2020, when I got down here, got hired at the Zebra on the test team as an SDET, was tasked with implementing performance testing. And the reason was because they had been crawled by Rachel Ray. Rachel Ray has a web crawler. And it had almost taken the site down. Like everything was redlining. They had to like impromptu, like the DevOps team was just like, oh God, we got to spin up replicas. We had a Kubernetes cluster, couldn't, but we had to change the policy on the fly. Her company runs web crawling. And my guess is it's to find links and useful things that they can put in, or maybe just to kind of do some web indexing stuff. I'm not exactly certain why, but it's because of how the caching and everything was configured, and because of how things were set up at the time with the auto scaling, we ran on a Kubernetes cluster. At this point in time, it wasn't like the Kubernetes side, the DevOps side was not well understood. It was just, as happens with many sites, applications, APIs, it had grown up over time kind of organically. It was a Django monolith, and it was architected to handle what it had handled thus far. They had never encountered an instance of being web crawled by someone like Rachel Ray. a lot of times what you find with software is the current implementation is the best effort implementation given the problems that have been encountered thus far and the scope and the scale that has been encountered thus far. It's only when you hit a situation like that and you find that things like performance testing are actually super useful, because it's very difficult to replicate situations like that, right? Or let's say, for example, you do a Super Bowl ad, takes the site offline, right? Or something like that. You just can't predict. It's very hard to, and it's even harder to like emulate that level of usage. So that's where kind of the forking around comes in.
And in
Yeah,
many ways, you don't want to emulate that, right? Like that's just like pre-optimization of like, oh, we assume we're going to get 1,000,000 hits. It's like, well, like let's just build to what we're actually getting, right? And so like staying within bounds is a smart idea just for time spent, right? And I feel like a lot of people have spent way too much time on their auto scaling when they don't need to. Like you could have saved all that engineering effort on auto scaling on just like over provisioning once, and that would have been okay for you in a lot of cases. In the case of this web crawler comes, and it must be hitting the site a lot because, I mean, you obviously you have users on the site in general that open links and go to the pages, but what is the web crawler doing that makes it all of a sudden, oh, one instance of a crawler makes us have to scale up the website?
exactly. And it's one of those things where in this case, it was the fact that we were shipping back a lot of HTML back and forth with the cache. And that was just absolutely just redlining everything. And also just the way it was crawling about the pages and all the way we had the links put out and all those things. It was just absolutely redlining it.
And so in that case, spending more money on the infrastructure wasn't going to solve the problem. You had to re-architect the actual functionality of the application.
Exactly. We had to find a way to re-architect things from the ground up and just be like, okay, we need to actually be much more efficient with how we're serving this. If we're going to use the cache to cache HTML, it can't be schlepping back and forth, entire documents and stuff like that. It needs to be very explicit, like snippets and things of that sort. Otherwise, network eats everything. This is something that I've always found true, which is network eats everything. Even still today, we have much better networks than we did a decade ago, 2 decades ago. Network still eats everything. And yeah, you don't want to pre-optimize. You don't want to solve for problems that are entirely theoretical. And over budgeting is definitely a good way to do that. Like during my data structure and algorithms class, we had a challenge to write a breadth surf first graph problem. And being the overconfident chaos gremlin that I was just like, I'm going to do it for C++. And I kept running into seg faults, memory errors, with trying to be smart about how I was reallocating memory. So finally just lost my patience. I allocated what ended up being like 2 gigabytes of memory, and it just read the entire file. And the professor didn't realize that I'd done that. And it handled the largest edge case, but it was very much brute force like, okay, this is going to work. Like if you feed me a bigger than 2 gigabyte text file, then we can talk. But at the same time, it's like when you start hitting those limitations, when you write things to solve certain problems, always make sure to leave yourself escape hatches and means of reconfiguring, rewriting, re-implementing things easily, such that you can go back and address potential scale issues. And at the same time, like performance testing is one of the things where people are just like, oh, that's like a tomorrow problem. We don't need to know that up front. I always say that if you had the right tooling, like if performance testing frameworks were more friendly, you would write all your unit integration, more so your integration tests, as performance tests, because then you could execute them at scale and you could get that synthetic insight. You could get the checking boxes side but of tests, which is does this break or not, but also you can get the performance metrics. You can get, particularly with things like open telemetry and stuff like that, you can get much more detailed insight to how your application's functioning, its memory usage, all these other things that let you identify issues much more accurately beforehand, so you can minimize the oh no moments. It's one of those things where this got down to the performance testing. So I'm implementing this. And the thing that I find is that a lot of these performance testing frameworks are very rough goes. They tend towards one of two extremes. There are frameworks that try to let you effectively write integration tests and execute them at scale, but they're terrible resource hogs. They execute pretty slowly, and they're just kind of a bear to set up. Or they're much kind of lighter, faster tools, but they generally only let you hit a single like endpoint. They're pretty limited in what they can do. This is what put me on this path of writing my own performance testing framework. It's one of those things where, as I've continued down this over the past 5 or so years, what I've increasingly realized is we really do need a new class of test tooling, which I've taken to calling simulation frameworks, in that they simulate user interaction at varying degrees of scale. And to me, this ideal framework is something that lets you write things as very small, compact unit or integration tests. Basically, you compose them as workflows, and then you execute them at the scale of a performance test. And that allows you to scale up, scale down. So if you really only need just kind of basic integration testing stuff, you can kind of bring it down the amount of concurrency. But if you need to really see where issues at scale might lie, where those little, hiding demons and grumbles in the code might lie, you can scale it up and you can actually do those things. And you don't have to change the code. You just have to change a config or a CLI arg.
Was this output like a direct results of what was happening, where you're just like, oh, site went down, we fixed it, we found it was caching problem, let me go build a performance framework? Like what kind of led, like, there seems like a gap in there.
Yeah, that's what I was saying, was like performance testing tooling tends to those two extremes, where you have tools that are let you kind of have that realistic usage, but they're not very friendly to use, or tools that let you just kind of simple usage, but they're very limited in what they let you do. And we tried using one before that was, we started with Locust. And Locust does a lot of things right. It's very quick to write tests in, but to get any reasonable scale out of it, you have to run it distributed. It's not very resource efficient, so it doesn't play well with the much more resource constrained environments of something like a Kubernetes cluster, especially back in 2020. And it has a very spicy distributed architecture where all of the workers must have a copy, the exact same copy of the test. So you can't just like on the fly update the test or rerun a job easily. You have to basically redo the deployment, or you have to, if you need to make a change to a test, you have to redeploy things and things of that sort. That gets kind of clunky. It also means that Locust has a very nice web UI. At the time I was using it, that web UI was really how they wanted you to interact with it. Well, developers, we're okay with UIs, but a lot of times we prefer command line tools. And trying to get things running via the command line was just a rough go. There are other tools that we wanted to try using, like K6. K6 probably strikes the best balance, but again, if you want to use it inside a Kubernetes cluster, you have to use their custom operator, and that is also a bit of a rough go. And so for me, it was these continual frustrations of just like hitting this roadblock. Oh, well, this doesn't quite work. Well, I have to write all this other code around it to get it to work in our environment. Well, I have to write all this other code to work to get it to work in an environment. Well, I can run it like this locally, but then I have to do all this other changes and work to get it to work in a distributed environment. And that's what pushed me to that. So what happened was, I think it was a time, is like the third time in as many weeks we were trying to run a test, and we kept running into out of memory issues in our cluster with Locust. And so finally I go to my manager. I'm just like, do you trust me? Yes. I was like, I'm going to go, give me like 2 weeks. I'm going to go write our own performance testing framework, and then I'll be back. And then I came back 2 weeks later and we deployed it, and it did the thing, and it worked.
Wait, you accurately predicted how long it would take you to write something? That is, I think that's the big story here. This is
the way engineering people have been like, wait, you made that engineering estimate work? I was just like, I worked a lot of long nights back then, because I was at that point, I was motivated. Have you ever had that when you're just like, I'm going to make this engineering deadline work because I now have spite?
Spite-driven development, so powerful.
Spite and ADHD hyper focused. Like, you know what I mean? Like when it's something that you're like, I have to figure that, like it bothers you. Like you try to go to bed and you're like, that's all you can think of. Like, and you're just like,
I mean, yeah, you should have said 3 weeks and slept once or twice, but instead
it was that. And like by that point, so we wanted to get the results into stats.d. And this was another thing that I found with a lot of performance testing frameworks is, if you wanted to get your results somewhere that they didn't support, it was just utter pain trying to get them to do. I had basically written an entire framework's worth of code already around Locust, getting our results into stats.d. The way I had to get it done so that it didn't completely tank the memory, because Locust was already being a memory hog, I had to use gRPC. Well, Locust uses gEvent, and gEvent and gRPC do not play nice together, and they would just hang the program unless you brutally monkey patch a couple of things. And I'm just like, look, Linda, I ain't asked for this. I didn't. This is actually when I was just getting active on tech Twitter too, and I posted some random thing about it. And one of the gEvent devs comes into my mentions and is just like, "What do you mean?" I'm just like, I don't know. You like the library, you tell me. Why don't you like Juvent? I don't like Juvent because it's breaking things right now, okay?
Like you have the most fire tech Twitter and now tech blue sky like feed.
Oh
And
gosh, we
like
didn't talk about my unhinged stuff.
it's made my life for like 3 years.
I
And
get
it just
spicy.
like but that's why we love it and stand for it. Like
I give full credit to like Ian Coldwater and like Kat Dennings and Corey and Angie and those folks for just like getting me to, because before that I was very much like, I have all the spicy thoughts, but I'm very terrified of saying them because I don't want to lose my job and because I know how the internet works. And if I say something like too, if I mouth off to a particular VC bro or something like that, I'm gonna ruin my entire career. And I just got out of Montana. And I don't want to be kicked out of tech, right? Like, I worked for 5 years to get above, poverty line in Montana, which Montana poverty is its own special kind of like. Ask Primergen about it. It's bad. Like, yeah, it's funny because Danny Thompson and I, we both share this background of like, we both worked graveyards at gas stations. And I remember the moment where I started like that push to get into tech was, it wasn't working, but I was on one of my runs and I was running down the street. I stopped at another gas station, same chain, and talked with one of the guys there. He was a friend of mine. And then I go back, and then 20 minutes later, it turned out he got robbed and got shot. That's when I was just like, I can't do this. Like, this English major isn't paying off. Like, I gotta go elsewhere. I'm like,
there's a stark difference, right? There is like the people that came from middle class families and like have never, experienced poverty and like all they know is tech and fancy stuff. And then there's the people that have English degrees and theater degrees and art degrees. And we've all clawed our way out of poverty. And we're just like, they let us do this every day. Like, you know what I mean? Like every day you're like, wait, is this my life? And then I'm just like, oh, but I have spicy thoughts. And I'm like, don't get fired. Don't get fired. Don't get like, and then I hang out with Justin too much. And then the spicy thoughts come out accidentally.
As someone who was almost fired for my spicy thoughts online, I will say, don't do it if you don't have a backup.
I mean, it's one of those things though, right? Where you're just like, you're so like, you start off so scared. And then eventually like, I like y'all's spicy thoughts, so I'm just saying that.
But it is just wild. That is like, I feel like I found my people of spicy thoughts and like different backgrounds in tech. And it's like, we're obviously all like diverse and different, but the similarities are just fire. Like, you know what I mean? Like, you're just like, we're like, like when you know what it's like to be the poor kid and we've all like got spicy takes and just, I don't know, like they're just, you can tell, like we were all built to be like a certain type of people. Like,
Well, and see, it's the thing where it's like when I was growing up as a kid, I got very like I don't hide the fact that when I grew up as in my household as a kid, like economically, my parents had busted their butt, and we were very much on the like advantage side. But on top of that, like we had house issues. Putting this in a very appropriate way, my dad, he's worked through it so hard now, but he had to deal with alcoholism that made growing up really hard. And so I was not used to saying also those spicy thoughts for the longest time, because if I mouthed off to my dad, it did not turn out well.
yeah, my family was very religious, but like either half my family was very religious or the other half was like very like did drugs and craziness. So it was like you had to be perfect to stay in the safety, you know what I mean, of the religious side. So I feel you. Like I was always like the opinionated child and it was not good.
I would love bringing that side into technology too, because there are a lot of people that don't feel they belong in tech because they're like, oh, my dad also went to AA, right? My mom was in rehab through most of my junior high and high school and beyond. It's like, this is how people live. Like, this is the reality of a lot of people's lives, and they don't think they can break out of it. They don't think that they can do something to get themselves out of that situation, which can be dangerous for their lives. And all three of us on this show right now are like, we've all come through some stuff. We've all broken out of things. I remember plenty of welfare Thanksgivings, right? Like people bringing us the food to like be able to have something to eat.
It is so embarrassing to have to like use an EBT card and all the things. But I think that like you can have your flavor of hard, right? Like it doesn't have to, everybody's background doesn't have to be exactly the same to know that you've been through struggles. And I don't think like the typical, like whether you grew up in poverty or middle class, there's still things that can happen in your life that makes
We're not trying to like outpour someone here, right? Like there is that like notion of, yeah.
like my friends will be like, "Oh, well, like I know you're going through this thing, but this thing happened to me." And I'm like, there's no competition on pain or struggle, right? Like we're all in it together. Like, and there are different levels of hard. And I think what brings us together is the fact that we got through and we tried to create it. Like when you come up as a kid that can't like really be yourself, you know what I mean? And then when you get to like you've made a life that is better than what you grew up with and a safe place that you can be yourself and then go seek out community, that's such a win because there's so many ways that you could have picked an unhealthy way to deal with those problems. You know what I mean? So the fact that we've got through it, we figured out how to build that life that we could have created our own safe spaces and then found our safe people. That is such it's an underrated win. You know what I mean?
Exactly. And it's one of those things where there's not a day I wake up now and I don't feel incredibly lucky to do what I do.
And I just love that you're out there being just like yourself. Like every time you just like a little bit more Ada shows and just like, yes. And I'm like, if you come from them in their mentions, I will find you.
I'm the same way. Like, don't come for my people. Don't come for my people. Like, Josie's seen this too. Like, I will light someone on fire if you come for my people.
But like,
It's
how
like,
dope is that we've created this cool community and we have each other's back? Like, that's so dope. And like, I got an art degree. Justin was gonna be a mechanic, but he's also the smart dude with like a mathematics degree. You had an English degree, and we all ended up in the same place. That's rad.
so my postbacks were actually in CS and applied math. Hey there, fellow math nerd.
That is amazing.
I wanted to do pure math, but it would have been another year because of how they had the courses lined up. I mean, it's University of Montana.
I was similar. Like I wanted to do pure physics, but the way it lined up, I had to have the math. And so I was like, all right, fine. This is, I want to graduate in 4 years. It's cool.
Sometimes the stuff that Justin just pops out, and I'm like, I know he's smart, but he just like says something, and I'm like, what goes on in there? And then you're on like the internet, and you're like, I built this thing with Python, and it did this crazy like hydro testing stuff. Whoa. And like, I'm just like, Ada, what? Like, do you sleep?
I do actually. I promise. I promise I actually sleep. But no, it's one of those things where it's just like the math side. I used to be terrified of math. And then the thing you end up realizing is that math at the upper levels is a lot more creative and like open to interpretation and stuff like that. And even if it's like applied stuff where you're writing systems of equations or you're writing solvers to solve kind of these very practical applied things. So University of Montana, case in point, their math department is very much oriented along the side of computational biology. It's really handy back right at 2020 because I knew how to write my own models and everything for COVID and did so. It's one of those things where it gets so much more fun as a large part of it. I will still always say this, like when I step into my complex analysis class, which for those that don't know, complex analysis is basically calculus with complex numbers and proofs, which sounds like three of the worst things you could ever put together.
Yeah,
But
you
it's
just gave
really
me like
cool.
anxiety. Just
I had so much anxiety walking into that class, right? But then you realize unless you do these things, because at this point you've probably taken like a multivariable calculus class, and you have had to solve things like basically what are called path integrals, basically finding a path,
The
right?
hardest class I've ever taken in my life. Yeah. Multivariate. Like I almost died.
It takes like 4 or 5 pages to solve these things. And then you realize with complex analysis, it's like a half paragraph proof. And you're just like, I did all that math for what? So at this class, you could show me, hey, guess what? There's an easier way. You didn't lead with it?
do you ever feel like you got like the answers in like a weird way? Like when I was younger, I was really good at math. And then I got convinced that I couldn't do math because I would always find like the weird creative way to solve an equation. And they're like, that's not how we learned in class. And it's crazy. Like if you look at the studies of how like girls don't do well in math because of the way that like we're taught and that we're doing it wrong or just the other things. I purposely got the degree that had less calculus in it to avoid it because I was convinced I was bad at math. And then I ended up learning math backwards through like programming and like different like computer like things because the like, you know, they share the same like kind of functions and like wording. And I was like, this was just a bunch of set of instructions the whole time.
It's basically it. And that's the thing for me is so much of math in schools. The problem is a teaching problem. It is how these subject matters are taught and the fact that we do not allow for students to engage in alternative methods of solutions. Because when you're at upper level math, that is encouraged. That's as long as you can prove it, as long as you can write out your logic and you can QED that thing, cool. But the rote memorization that is expected until you get to the point, the fact that we purposely make learning the mathematics and learning computation suffering up until you get to that level is just the most backwards thing to me. It's frustrating. It's so deeply frustrating because if I had $1 for every person I've met that is actually fantastic at mathematical and computational thinking, but has been just absolutely clobbered into thinking that they're terrible at it because they have had teacher after teacher after
And how
teacher
many of them were
tell them
neurospicy?
neurospicy or exactly.
And it's so wild because like Einstein, like Sebastian Bach, like all these, like every big person in history that had some like monumental like change or figured out like something that we are going to learn in textbooks, we're told the same thing and we're very neurospacey, but we only teach for like a very small subset of like the population.
For me, that's the biggest thing about the work that we do. Like I said, that creative aspect is that it encourages this exploration and this alternative problem solving. And it's just like, it's so incredible. Like when I worked at the code school, and if that code school had not unfortunately failed, I would still be working there because I loved that job so much. Seeing adults find that like childlike wonder and love of learning and desire to explore again after they've been told for their entire lives that there is one way to do things. This is the way we do things. If you don't, you are punished. It is the best feeling in the world. I still live for that. That's a lot of why I like to build things like internal tools and stuff like that that bring joy to programmers because it lets them explore and be creative, or like libraries that let them solve cool things.
Just allowing someone to be creative again and to be a beginner again is a huge win in so much of this. But you just mentioned something that I did want to get back to, your performance testing framework that you built in 2 weeks, because we kind of stopped the story there and went on a detour here. But then you now built this thing and it sounds like it was successful. Is this something that's open source? Is it something that other people
It is
should
now.
be able
There's
to?
a version of it that is open source. Yeah. So there was an original version I wrote that was a decent implementation on its ideas. The newest version that I'm working on is called Hyperscale. It's under the Hyper-Light organization on GitHub. I am working on it. The CLI is working. It's available as a Python package. You can run it. I've got a bunch of stuff working in the past couple of weeks. It is very much under active development. It has a full CLI. It's all Python written. And what it is when I originally wrote the initial version, which was called Hedra, which is a terrible name. It's the best thing I come up with because like it does many things. It's, I have a huge gon.
I
Okay, I'll
thought it
just
was a
steal from
cool
that.
name. I thought it was really cool.
It's math nerding. It's math nerding. And like it's just like Hudragon. Yeah. The thing with it though was like every time you try and implement something like this, it gets part of the way to the actual vision that you have, right? And it gets down to this idea of like best implementation at the time, given what you know, given the limitations that you have. So it did well, but there was a lot of baggage with it. It was really clunky. It was not going to work as well distributed. And there were other like architectural decisions that I made with respect to like Python's multi-processing that made it feel really janky to use in my view. And this newer version, Hyperlight, it uses a very different architecture and very different like implementation, and it has a much more simplified API, and it's so much cleaner and nicer to use. The UI is very informative. It's entirely custom written terminal. All those terminal graphics are done via a component library that is in the Hyperscale library itself that I have written.
Which FYI, your website's down, hyperscale.dev.
Hyperscale.dev? That is not a website that's up, actually. It shouldn't be up.
Okay. I'm on the GitHub. That's where it was linked.
Oh, you're on the GitHub? Interesting. I'm actually working on updating that right now. I need to update the screenshots and things like that. But if you do like a pip install or my preferred tool of choice, UV, which by the way, shout out Charlie Marsh. Goodness gracious, that man single-handedly changing the entire face of Python development.
I didn't know you could use UV over pip. That's awesome.
I love UV so much. I have never felt such love for a package manager.
The way you were so passionate about that made my heart happy. You were like, look.
I love how fast it is. I love how easy it is to set up virtual environments. I love how good the resolver is. I love how clean and concise the messages are. I love the fact that it has built-in log files that are actually nice. This isn't to say, again, past efforts like Poetry and stuff like that, best implementations given what we knew at the time, but UV just nails it.
This is the second episode. The episode with Sam, also, we were talking about UV for a little while and just like how much better it is than what came before it.
UV is so good. Like Charlie Marsh is single-handedly changing the entire face of Python development. Y'all got to understand, like between Rough and UV and things like Pydantic, modern Python development is so different than what people have expected from the past. It's in like the type hints are getting better with every version. Python's event loop is ridiculously performant now. Every version since like 3.10, it's gotten so much faster and so much better. And it's really good now, and it's like with the sub interpreters that are finally coming in 3.14. Well, they've been there since 3.13, but they're going to be publicly accessible as an executor in 3.14. And you better bet this framework's going to have that we're going to switch over to that. Python development is really just the language is growing up and is changing in a way that is absolutely fantastic. And
Which is
I
amazing
just,
because Python was out there longer than most people think it was, but it's grown so much in the last couple of versions. And that was always everybody's complaint that it wasn't performant enough. And now they're putting so much effort.
Well, and everything that you just mentioned as far as performance goes, right? Like Rough and UV, they're all written in Rust, right? Like, which is a very interesting take on tooling for a language that's not written in the language, right? It historically has been like, don't do that, right? If you're writing something for the Ruby ecosystem, it should be written in Ruby because we're going to maintain it going forward. And this idea that's like, actually, let's just pick the more performant language or something that is better to distribute with CLIs, like just let's write it in Go or Rust or something else that knows how Python works. Maybe that's the better route for some of these things. And that seems really interesting.
It kind of makes sense though, because just think about it, when they make languages that don't need to be compiled, they're usually on top of a language that is compiling, right? So it's like just another version of us kind of learning new ways to build things and to make them more performant, but make it be more accessible. Because let's be real, if I'm gonna teach someone Python over Java and teaching them how to account for garbage collection or C++ and pointers, it's just they're all on top of assembly. You know what I mean? Or like whatever kind of like, it's all just another abstraction.
You know when you're driving down the freeway and you see one of those billboards that say your ad here? This is basically the audio version of that billboard. This is Justin Still. We are still looking for sponsors for this podcast. We are having a great time learning with everyone in the community about how infrastructure works, how people are adapting to problems, and even looking for solutions that solve some of those problems. We don't do pay-to-play episodes, but we do love to promote people in the ad spots so other people can learn about what you're doing. If you are a sponsor and you're looking to reach this audience of developers and engineers, go to fafo.fm/sponsor and check out our packages.
Yeah, and that's the thing is like I do actually get in a lot of ways why Rust would be a good choice, particularly Charlie Marsh, because like C and C++ and C Python, all those things, that comes with a lot of baggage with it. And it's just like, if you've ever looked at the C Python internals, it's a lot. It's a lot to take in. And so having messed with Pyo3 and Rust, it's such a nice, clean interface to build all the core guts that really matter as something super performant, very memory safe. Like that makes a lot of sense because you don't want to have to worry about memory leaks with a package manager. You don't want to have to worry about, global interpreter log and all these other things. You don't want to have to worry about all that. It should just work. And then you have a nice interface.
Also, that seems to be where people really want to put Rust. Like, I think some people look at Rust and they're like, I just want to build everything in it. But as far as big companies and really like when we're starting to rewrite like whole programs in it, people are picking like very specific places that you need the memory safety, you need the performance, and just rewriting that. So I think Rust is going to be one of the few languages that you will pick a part of your architecture or program and completely rewrite that section in it, but still maintain the language in everywhere else. But just the important guts like a kernel or memory node, or you know what I mean? Like this, like package managers, that will get rewritten in Rust even while they maintain the programs in other areas in the same language, because I think that's just going to be the new implementation for Rust.
As a general question, one of the benefits obviously of Rust is like, oh, it's memory safe. It's because you're manually managing the memory, you don't need a garbage collection, you don't need to do all that stuff. But then also I think that like CLI tools they run for less than a second most of the time, right? Like I'm running it for a couple seconds or something. And maybe the memory safety would help me with doing some passing information through that I don't trust. Like it's arbitrary. And how many times was there a critical vulnerability in a font? Because fonts are basically like rendering engines that you can pass different data to. Like there's all these like weird places where it's like, oh, I don't know the inputs to this thing, but I know what the output should be. And if we send it garbage in, we get vulnerabilities on the outputs. And maybe like Rust is going to help there. But how much of the other things that Rust does really matter for something like UV? For something, and this is something I'm generally like, I don't know the answer to. If any listeners know, like, what other benefits are there to something like this? I've used like Go as a garbage collected language. And it's like, I don't care because I don't run a CLI long enough to collect garbage on it.
Right. And it's one of those things where it's like, for me, with when I take a look at Rust and writing things with command line tools and like that safety and that performance and things like that, you would think it wouldn't matter. But it's one of those things where when you, particularly in things like Python, when you have things like global interpreter lock kind of lurking around, that can potentially result in some unsafe situations in various environments and other things too. It's just the way that I've heard people argue for Rust in this case is when it comes down to things like that, where it's, a couple seconds of interaction, what's really the benefit in terms of performance and speed up, and why safety when it's just, a couple command line R's. It's not like we're ingesting, 50 terabytes of data and things of that sort. The biggest thing I've heard is that it's the stability in terms of releases is what it is, which is it's a long-term investment in developers being able to improve and expand upon the tool and being able to release consistently and knowing that things won't break. So that way, when you get a new version of the tool, you know that if there are bugs, they're not going to be like memory violations and stuff like that. And it is also security in some cases, because there are a lot of cases where folks will try to they'll try to use CLIs for exactly what you're saying, garbage in, malicious data out, right?
Yeah, I can fuzz a CLI or something and see what happens.
You would be surprised. Datavant is a healthcare company, rather large. It's a realistic security consideration. We have to lock down a lot of stuff inside our images so that people can't run it, because people will try to see what they can get away with injecting into, for example, Maven or Java or Javac or UV or pip or other things, to see if they can get some access somewhere else that program has license to run in. So, and then but also just on top of that, it's one of those things where it's the other part of it, I think, is when you're releasing something like a command line tool, the expectation is that it should just work, right? You should be catching memory violations and stuff like that out in live, and tools like languages like Rust and stuff like that really tend to help with preventing that sort of thing early on. It's kind of shifting it left.
I mean, as a consumer of a lot of these tools, an occasional writer of some of them, like just the distribution model is so much better for compiled languages, where I tried to install a background remover that was written in Python, and I was like, I give this a 70% chance of succeeding. And sure enough, it failed, right? They would not even go through the install because like I can't get the right dependencies in your distribution, whatever. And I'm like, yep, that's what I thought. Getting a binary and only relying on the C libraries or something, is usually going to be better for me. Are you doing performance tuning and stuff at Datavant, or are you doing like a data backend? What's your role there?
I'm internal services, internal tooling, running in Golang, actually. It's funny that you bring up Golang. So Golang, API, CLI services, things of that sort. I've also written a whole slew, of course, of internal tooling and like Python and things of that sort for them. Datavant's very multifaceted. So we have parts of the organization that run very heavily on very legacy, like .NET and stuff like that. And then we have parts of the org that run almost exclusively in Python. A good swath of the org services are exclusively in Python. And then we have another part of the org that uses a lot of Java, and like the thing that my team does.
So you're an enterprise.
Write a lot of deployment. Yeah, we're an enterprise.
That's all those places. You're enterprise. This is.
And so what my team does is we bridge all that by writing a lot of like deployment tooling and stuff like that in Golang. And Golang is interesting because Golang, not necessarily before Rust, but it certainly became hugely popular with a lot of infrastructure stuff. So if you want to work with like infrastructure libraries like etcd or like the Kubernetes API and stuff like that, probably the best way to do it is something like Go. And particularly if you want to turn it into a service or a CLI tool that interacts with those things, that isn't to say that you can't do those things.
This was like Docker was built in Go, which was like maybe a bad call for them early on, right? And it was just like they did that really early and they went all in. And now everything in that ecosystem, if you're interacting with the Docker API, Kubernetes, whatever, it's all Go.
It's a huge part of it. And it's one of those things where, so for my team, the reason we went with something like Go as opposed to Python or something like that was, again, that redistributability, the build pipeline and stuff like that. The fact that we can just build a binary, set it as cross-platform, build a different architectures and just deploy the thing. Whereas with Python, you have to worry about selecting the right Docker image. You have to worry about building things for the right, architecture. You have to worry about, everything being installed and having available like versions that are available and compatible if you have a package, but that package doesn't support Mac, for example, which was a problem when like M1s and stuff like that came out because the underlying C code hadn't really become compatible yet. That could be an issue. It's just one of those things where I, in particular, so it's funny because I write a lot of Python, but Golang is actually my favorite language. Go and Rust and these other languages just let you take care of stuff so you just don't have to worry about it. And there's an upfront cost, particularly with Rust. With Rust, the upfront cost is high because you have to learn about a set of concepts like the borrow checker and things of that sort that are just kind of intense. They're taxing. They're upfront. It's not like C or C++ where it's kind of, fork around and find out. You learn about how not to mess up memory as you go, as you get as you encounter seg faults and stuff like that, which, as you get experience enough in C and C++ and things of that sort, you start learning more and more. So it's like when I'm writing C++ anymore, I try and use I'm very careful with it, but I try and use things like shared pointers and stuff like that, even if they are less performant than just mallocating or reallocating memory. I know how to do that as well. I also know how to do unhinged things with like compile time template programming in C++ that no one should ever do.
Can you
Well,
tell
very
me
select
about
people should ever
those
do.
things? Because like I have questions.
Oh Lord. Oh yes, yes. That all came from a professor we had in my last year called Oliver Saring, who remains one of the most brilliant people I've ever met. But good Lord, the things that man knows how to do with C++ are truly unhinged and beautiful. It's things like you will compile a program and you can use template programming to, at compile time, whilst determining the types of compiling the program, do you use like constructs like recursion to do like loops and things of that sort to allocate memory and like templating construct calls and to perform operations and things of that sort. So the way Oliver and I would use this is basically for like tensor libraries for scientific computing and things of that sort. We would use that to basically set up tensor computing ahead of time because you have a static file there. So you know the size, the params and all that stuff as you would need to do at compile time. And it can just take care of that in compile time so it doesn't have to do it during runtime. Would I recommend doing that for like a C++ server program? Like, should you go, build your Drogon app with fancy, compile time vectors and stuff like that? Probably not. Is it maybe a useful trick to do for scientific computing where a lot of times you have access to the data set ahead of time and those parameters are known? Potentially. It's a trade-off. And this really gets down to the idea of like optimization and things of that sort. Again, kind of going back to the performance framework and stuff like that. The thing you end up learning about optimizing frameworks, and particularly with like performance frameworks like Hyperscale, is optimization. You can reduce the amount of work, of course. That's one way of doing it, which is you remove work. That's done. You can shift the work elsewhere. You can do it at a different step, at a different place, at a different time, and get out of the way of things, right? Or you can like distribute the work, right? You can kind of spread it out so chunks get done more quickly and then you bring it back together. And one of the things I found with Python is that there's a lot of introspection features that are available so that you can introspect from types and arguments of functions and stuff like that. So one of the things I found also with things like Locus and stuff like that was that they were doing a lot of DNS calls and stuff like that while they were running these tests. I was just like, well, it's like, for example, if it's like a static string, right? If I'm just hitting http://bin.org/get, that's a hard-coded string. Why do I keep doing these DNS lookups? Like, why am I invalidating the cache or anything of that sort? Like, this is a static address. So one of the things Hyperscale lets you do is you can set default arguments and then specify using a type hint from types that the library provides you that this is like a URL or something like that. What Hyperscale will do is shifting that work. It will go in before it starts running the test. It will do the DNS lookups, or it will like serialize and turn your data into bytes or your headers or stuff like that. And again, it's that idea of shifting work and just like, hey, if you're going to tell me that this is just static and you're not changing this isn't dynamic, we can optimize that ahead of time. And that makes it much faster.
DNS lookups can be a big performance bottleneck, right? If you are like, oh, you know what, this I missed the cache, let me go look it up. Oh, it's not in my local network. Especially if you're running like your performance testing containers, right? And you're basically starting with a clean slate every time, and you're like, oh, now I need to wait to go find the next answer. If that downstream server is affecting your performance results, that's not accurate necessarily. You're like, oh, I must have shifted something that is really slow now. It's like, actually, well, no, you just DNS was slow, right? We can make sure you get that ahead of time.
Exactly. And so one of those things are you performance testing the DNS server or are you performance testing your actual API and stuff like that? And it's also just things like, are you performance testing like your server or are you performance testing how fast Python can serialize a string, which is fast-ish, but still. It's overhead. And this even comes into a bigger role when you have things like HTTP2 and things like that, where the serialization of headers and all these things and the encoding and the HPAC headers and all that stuff can get very expensive if you have to repeatedly run it. It's one of those things where I went through and I took a Python HTTP2 library and I basically wrote a bunch of it, kind of removed a bunch of bottlenecks and efficiencies and things of that sort, simplified it down so that it's much faster. I then took the HPAC library that it had that was pure Python and I rewrote that. So it kind of optimized that and turned it into its own thing. It's still a good amount of overhead, whereas if I passed in just static headers and I do all that ahead of time so that I'm just passing in the pre-encoded headers, that's saving a lot of work. Other things too, with a lot of these frameworks, I think even within Locust, you could have different types of locusts making different types of requests. But each locust could have you could have an HTTP locust, you could have a fast HTTP locust, you could have a gRPC locust. Well, the way modern services work is you could have a web page that is making calls to any number of these things. And then on top of that, you also have the web page. That's a part of your performance, right? So why not make it so that when you're writing these workflows, you can use multiple clients within a single given workflow. So I can simultaneously and admittedly from the same concurrency pool, but still at the same time test at the multiple horizontal layers of that stack. So I can test using a Playwright integration that my web UI can handle 1,000 concurrent users. And then I can test at the API layer that, all those backend calls that I'm making can also handle that additional traffic and things of that sort. And I can test and it goes on down the line, right? Or if I need to make some sort of HTTP3 or UDP call, I can do that as well, right? And it lets you just be much more creative and expressive with your tests and really get down to what am I really needing to test and what do I really need to see? That's the thing with simulation frameworks that differentiates them so much from more traditional performance testing tooling is this idea of really focusing on how do I get the insight that I need as opposed to how fast can I hit something? And it's what differentiates them from traditional unit and integration performance testing frameworks in that it's does this break, check the box versus what kind of data can I get back from this? What's my memory usage over here in the server? What happens when I make this extra UDP call? What happens when I add a probabilistic variation, right? And there's a 50% chance it will make this request because I've put that in my test in the workflow, right? So I can add a little probabilistic bit in that chaos testing side. Or what happens when I add a mutation and it inserts some malformed headers or some extra junk data at the end of an HTTP request? Does that trash us? Does that really hit us?
I feel like a lot of the future for a lot of these things is shifting from here's a bunch of data, you make sense of it, to here's some understanding that if you ask the right question, hopefully you know the answer to that without just throwing a bunch of numbers at you. Because as much as people can understand and do complicated math, people aren't good with numbers generally, right? If you just throw just throw a bunch of numbers at me, I don't know, let computers do the numbers, right? And so letting the computers figure out what the meaningful answer or meaning of that number set is probably a better way to interact with any of these testing tools of saying was it faster? Yes or no? Okay. Well, does that matter? Does it matter because I ran this one on a Raspberry Pi and that one on a 84 core server? It's faster, right? So that's not actually what we're trying to get at. We're trying to see how much does this cost, or how much do I need to scale it up, or how many replicas do I need, or more practical business applications to things outside of the code, not just here's a bunch of data, let's apply the data. It's okay, well, how does that data fit into the rest of the organization, or a Java application versus Python versus, Rachel Ray crawling my website, right? All those things are real world concerns that aren't just numbers.
Exactly. And that's the thing is that at the end of the day, a lot of software that we write comes back down to dollar value and things of that sort. And the metrics that we get, we have a glut of metrics nowadays. With testing, it's much more challenging because testing tooling as is right now does not do as good a job of exposing and I mean just barely exposing metrics and numbers as it should. It's kind of the first step. That business logic step is really what's key. And that gets down more, at least in my view, to like having good integrations with reporters and things of that sort. So like for Hyperscale, it has an integration with like 31 different reporting options, Datadog, PostgreSDB, you name it. And that just gives you that freedom to be able to tell that business story. Because if I'm just outputting a bunch of timing results to a JSON file, that doesn't tell a great story. But if I can publish that to a Datadog dashboard and then have that dashboard set up such that it's, to like you were saying, it shows that dollar value of like, this latency is costing us this many dollars. This many requests because of how much memory it's using is costing us this much. That tells a story. That's something that I can go to a organization leader or something of that sort and say, hey, this is the dollar value. This is the story that it's telling. Like the reason why we need to optimize this cache, even though Rachel Ray seems like a one-off instance, is because the story that's telling is that our UI is costing us money because of how much we're shipping back and forth. It's instability, so that it's an issue once right now, but it's going to become more and more of an issue as we try and ship more and more data back and forth as this application goes. And as we keep following this pattern of shipping these very complex documents back and forth using this cache, it's going to slow down other things. And it's going to become more than just Rachel Ray calling. It's going to be the average user hits the web page and it takes seconds to load because it has to go out to the cache and hope that it's there. You hope that that document's hot and ship it back.
I feel like testing and security, because it's harder to show business value until something bad happens, is always underrated. And it's so hard to get funding and for people to take seriously. And then something bad happens and they magically want you to save the world. And you're like, dude, I've been trying to tell you. It just sucks because being reactive costs so much more money. You know, being reactive makes you so much more vulnerable. But it's like you can talk to your blue in the face about being proactive, and people don't want to be like.
And that's exactly what this sort of understanding helps you do too, right? Because if you have some of the frameworks and data in place, like I can't tell you how many interesting problems I spent half a day investigating how much money it cost us and realize I'm like, oh, this is only like $100. Like this is like, as interesting as a problem as that is, it is not worth the time fixing. And it is not like we can just spend another $100 next month and it's okay. I will go find another problem that's actually worth spending time on.
Corey Quinn heads up the Duckbill group. And this is something that he always impresses, which is like, we're aiming to optimize items that are, millions of dollars off your AWS bill, not hundreds. Right? Like if it's a couple $100 a month, that's pocket change for Smurry. We're looking at hitting the big items. And it's the same thing. It's something that you learn when you really start pursuing optimization in general, which is this idea of, and performance in general, which is like, what is the amount of effort you're putting into this task versus what is the return? And can you actually quantify that? Right? Is it really worthwhile? A lot of times, like I've seen developers just go on perfectionists.
Ideals.
Yeah.
Ideals get in the way.
And admittedly, I used to tend to that side myself. I remember back when I was at the code school, I got in a debate one time with a fellow instructor over whether or not it was more important to teach for loops versus the math methods. It's just like, well, if they don't know for loops, they don't know basics. So he's just like, okay, yeah, fine. But then we need to get them on board the methods as quickly. It's just like, but like they're less performant. They're not as good. And it's just like, it's like, who cares? Like it's so much more readable and clean. And this is what's going to be expected of them at the job. And that was one of the times where it was this awakening of just like the business value, right? The amount of money spent in that time it takes the developer to write a good, clean, well-maintained, correct for loop that hopefully doesn't break or have a one-off error, whatever it is just so much more than it would take. Like it's so much more than the cost of the iota of compute more that it uses to run that map statement or that filter statement.
And that is like, you mentioned like the readability, like the maintenance of software is so expensive.
It's huge.
And that is why, like, that is what I want this podcast to be about. It's not about writing code. It's not about like the fun, like cool new tools. Like this is like the legacy podcast, right? This is all like, hey, the stuff that makes money, right? Like that is the stuff that in so many developers, they get into it because they're like, I see all this money that I get paid by being a developer, but they never want to boil their own like job function down to a dollar amount, right? They say like all the other people, like the salespeople, I can put a dollar amount on. The marketing people, I can put a dollar amount on. Legal, all these other like functions in the organization, they can look at and say like, oh, those all are here because they cost or make money in some way, but I'm the developer. And I feel like there's this hard thing where, yeah, like developers need to just open their eyes and say, oh, how much money is the feature you're working on worth? And how much is it worth in a year or two, like that is where you start to extrapolate it out and say, now maintenance matters, and now performance matters, and now all that other stuff matters more the longer it exists.
I think we're in this realm of like the toxic 10 times engineer, like everything is so technical and I'm more technical than you. And look at how I wrote what could have been 3 lines of code and 1 line of code, and writing code as fast as possible and not understanding the business impact or just the way that it impacts a huge code base in general. Like we are lacking giving people context, and we are lacking forcing engineers to be able to understand business stakeholders and the fact that what you build, right? So like if you're just worried about flexing technically, you're not even making sure you're building the right thing. You're not making sure that you're building a thing that brings value. They just want to flex technically.
Well, we've always praised the firefighters, right? We've always been reactive when you always said, oh, wow, you fixed that outage. Congratulations. Like, yeah, but the person over that's like, here's the emails I sent 6 months ago that said we're going to get into this problem.
See, I'm the 6 months ago person who's like, bro, like not just that, but think about it. It's a team sport. Just because you wrote the code doesn't mean you're fixing it. So if it's shitty code or if it's very unreadable, when somebody else has to come up behind you on call and try to figure out what is wrong here, you're costing engineering hours in that moment, right? Like it's not just about how fast you can write it, but is it going to cause other people to like, and just like Ada was talking about earlier, like when you re-architect things right, you're asking for engineering hours. So when you go and rebuild something, build it right. Take in the context and then go back and make sure that you're building it in a flexible way that will scale and that is right for what this product is now and what it's going to be moving forward. And people don't take that in, and then they're like, where did we get all this technical debt? Bro, you built it into it. Like, you know what I mean? Like you can't always account for the future, but with where we are now and the amount of technology and how much infrastructure grew, you can at least try, right? You can at least, and we don't put any emphasis on that as a developer. It's about like, how fast can you build it? Yada, yada, yada. But it's not enough foresight. Like we need to be able to be the people that have context, bring in the requirements, talk to stakeholders, figure out your business value and how to communicate that to your leadership and stakeholders. And we have lost that as engineers because, but look, bro, I can write 500 lines of code in like an hour and completely burn things down because I tried it and I built it fast. Like, no.
And that's the thing. That's the thing. And it's just like, this is something that, okay, we're getting into spicy take time. There's a two-pronged side of this, which is that one, we have glorified the writing of code itself and what most people don't realize is that every line of code that you write has a cost. It is debt that you are writing. And when you write a bunch of stuff quickly and make a bunch of decisions, it'll work for now. You are not just solving something. You're taking out a loan against, if it's just you, your future self, but if it's not just you, the entire rest of the org, potentially the rest of the business. And at some point, you are going to have to pay that debt. And you had better really hope that you get to pay that debt before things blow up, before things get big, because otherwise you end up with things like MySpace, where they literally had to get put out of business because they could not re-architect their app to beat the competition.
I love you so much. Like, you just be like, you understand my heart. Like, just, dude, like you sit in rooms and you're just sitting there arguing with like 3 different engineering managers and you're just like, bro, like.
You can give me 2 extra weeks to write this now and get it okay, like get it done well. Or yeah, I can sign this out in 2 weeks, but we're going to be back here in 2 months and it's going to be bad. It's going to be miserable.
And think about the amount of engineering hours if you do it double. Like if there's 10 engineers doing it, right? Think about how much engineers are paid. Think about the hours you're going to take to redo it in 2 years. Like that's so much money. Or just like when people try to tell you that like the cloud is like certain parts of the cloud are more expensive than on-prem. Some of them, they really are, right? But they don't count in like the people cost. So like if you have to hire a DBA, or multiple DBAs, that also costs money. So you have to weigh them in a actual, like, you have to really think about it, right? Like, and weigh all of the cost and the technical debt and everything. So sometimes, like, people don't even realize how expensive cloud is going to get because they didn't take everything into consideration. But then they just automatically assume on-prem is cheaper because they're only thinking about hardware, right? So it's like there's just so many technical, like, gives and takes that people forget to do. And we have just incentivize the work fast and fail, or work, what is it? The fail, what is that stupid
Move
saying?
fast and break things? Or
Yeah. And like, which sometimes you do have to break stuff to learn how they work, but you don't have to just be completely obnoxious and just a bull in a china shop. This, like what you said earlier, this is a creative art. Like it is almost an art, you know what I mean? And it is very much problem solving and see how things work. Then you can nicely break things. You know what I mean? Like you can break things in a way where you're learning and you're like, okay, if I like put this print statement here and then like, you know, comment out this line of code, but you don't have to take a whole thing down just because you're an idiot.
Like it's the difference between like making a sculpture and taking the time to make sure that it's, you know, placed well, that you aren't invading your fellow neighbors' properties and stuff like that, and just building a sculpture and burning down everybody else's houses around that. Like that, we have a guy out here in the neighborhood that does metal sculpting. And this is an HOA neighborhood, but he does it in such a way where the HOA is completely unbothered by it, even though he shows it all out there, because he is so careful about how he constructs things, and he's so conscious about when he does it, what time of night, how much noise he's making, all these other things. And it is, good Lord, if developers exercise that amount of general situational awareness when they build things, we'd be in such a better state.
And when you all end up in on call or something gets messed up, who do you want to help? The dude who is considerate or the dude who breaks stuff and is just a jerk and thinks they know everything, right? Like, who are you going to stay on that call with? Who are you going to, you know what I mean? It is a team sport. You need each other.
I've exited calls because of individuals like that, because it's just like, okay, I'm going to come back once we need a little bit more time to let this like simmer a little bit. We need some time. There's a couple other people here in the call. I'm going to take a break real quick because I've got another thing to attend to. I'm going to come back and we're going to handle this like mature adults.
I think eventually we're going to get to the point where these things make us better. Like we know what makes us better engineers. And I think eventually that will be, you know, looked on well. But honestly, like, okay, low key, not to get too spicy. I just hope that Dodge goes so wrong that we can get rid. Like, I want something to point to be like, did you see it though? Because like, I'm so tired of existing in toxic tech bro engineering and just, you know what I mean? Like we all know, we've all built things and we know that you need the emotional intelligence and you need communication skills, and leaders can tell us this. How many times has Kelsey and Angie and all these amazing people put these in talks and told the world that this is what we need and it's important to building technology, and still we're here. So I'm just like, what level of like fork around and find out do we need to do for it to trickle down into like hiring? Like, I don't know.
And that's the other thing too, is it's just like, the other part is like the VC capitalism thing, which is where the Elon Musk bro side really comes in, which is we just need to, you know, move fast and break things. We need to skill up, and it's the emphasis on features. I am so sick of new features, and not just the AI stuff. All the AI stuff is the worst offender. New features being pushed down upon me, that I literally have an entire studio in the other bedroom that is 2000s kit only, is completely disconnected from the internet. If I want to install something, I have to come over to another computer, insert a USB drive, copy the installer that, you know, is from that I download from whatever VST plugin maker that I may want to use, or things like that. So if I want Serum, I have to go over to Serum's website, download, put on the USB stick, come over and install it. And it makes this whole thing where it's just like, I don't want your updates. I don't want Roland Cloud pestering me to install or to log back in because it can't remember that I logged in 16 minutes ago.
I have an old iMac and I gave it to my kid and I was like, never touch the update button. And then he did one day and I was like, oh gosh. It's like, don't do it. But okay, do you ever watch those VC dudes and the Elons and then just be like, tell me you've built some cool stuff for 2 seconds and you've never maintained anything in a real environment? You know what I mean? Have we all just been waiting for them to figure it out? Like, you know, just
in many places, especially the last 15, 20 years, you know, post.com boom, sort of like this new wave of cloud, people have jumped jobs and technologies so frequently that they haven't had to maintain anything.
Me and my friend were talking about that. Dude, also, okay, there's a different level of like tech bro confidence, right? Like they will come in, they will delete 16 lines of something, do some other stuff, and with entire confidence and not even think about the future. Because for one, if they just pretend to be confident, the ramp up period for so long was like what, 6 months to a year. So they weren't expected to know anything for 6 months to a year. Then they just had to survive for like a year and they were already job hopping to the next job. You know what I mean? So they like, sometimes they weren't even actually like, we don't even know if they were good at like the first 2 jobs. Like, you know what I mean? And then they're just like in there like advising about stuff. And like sometimes I walked into rooms and people will like as an SA, these are all people that supposedly have been in, you know, industry for 15 to 20 years. And then like senior SAs or like L6s or L7s would walk in and tell you something. And I'm like, bro, have you ever built anything in production?
That's a scary feeling. Oh, I've had that.
Like, but you're over here telling so many people how to build things with this very like,
let's use a Cassandra database.
I used to work on Cassandra. Oh my God. Don't get me started on the scaling of the.
Oh, everybody thinks NoSQL is fun until they have to actually maintain it.
We are already over time. Ada, thank you so much for coming on the show. Where should people find you to hear more of your spicy takes?
I believe it's adalund.dev on Blue Sky. That's where you want to find me for the most part. My GitHub is /adalund. That's where you can find me there. Those are really the 2 places I'm at nowadays. And I just want to say thank you so much for this. Yeah, Autumn, I'm with y'all. Living through the consequences of your actions is really what it is.
I'm so excited to finally virtually like meet you. Cause like, look, I have like been one of her biggest fans for like years. Okay. Like just the spicy takes, like I live for them.
And you are in the, we have a starter pack on Blue Sky with guests on the show. So if anyone wants to, you're already in there. We're recording this a couple weeks before it comes out. But yeah, so if people are on Blue Sky, FAFO.FM, there is a starter pack that has all of our guests. I think we're going to break it up by year because there is a limit. We can't scale it past 150 or whatever. So
I love that feature. Talk about things that are actually like thoughtful and well put together starter packs.
Like Blue Sky has been a nice experience.
And also like, I also hear the people that are abusing it in various ways, and it's like you can't, no feature ever.
We all know perfect, that you build software and you can never intend how people are going to use it.
People will use it however they want to with whatever intentions they have, and that is unfortunate. But we are trying to use it for good.
Yeah, exactly. It's like the performance testing framework that could be used to DDoS the site.
That is exactly how Locust and things have been used.
Consequences of your actions, right? And it's one of the things where it's just like, but yeah, thank you for this. I'm so glad I get to meet y'all.
I'm so glad I got to meet you.
Thank you everyone for tuning into this episode. Your homework for this week is to please rate the show and leave a comment with whatever you developed out of spite. We would love to see what and
send us like your best programming memes, because we need I think we need like a meme competition of like your best nerdy meme.
I'm immediately going to go for Emperor Palpatine. Let the hate flow through you.
This is why y'all follow Ada, okay? Gem.
Thank you so much, everyone. Thank you, Ada, for coming on the show. We'll talk to you all next week.
Y'all take care. Later.
Thank you for listening to this episode of Fork Around and Find Out. If you like this show, please consider sharing it with a friend, a coworker, a family member, or even an enemy. However we get the word out about this show helps it to become sustainable for the long term. If you want to sponsor this show, please go to fafo.fm/sponsor and reach out to us there about what you're interested in sponsoring and how we can help. We hope your systems stay available and your pagers stay quiet. We'll see you again next time.